Good morning, and once again welcome to my YouTube channel, Maths with Ease by Mr. Kamotho. And in this video I'm trying to explain activity 1 in handling data 6. And we are told that a company wishes to investigate how effective their brain training program is. We are told that they first test how long it takes to solve a logic puzzle. Then they allow the participants to use the program for a week, and then they test the participants again. We are told that they first test how long it takes. The key word is how long. 2 sets of data were gathered from the same group of adults. The data shows the time taken to solve a puzzle before and after they have taken the course of brain training. And I want to just explain the table. It looks so much details, but I have chosen to work out this question before and then come back and explain it. Originally, the table had the time taken in seconds. These are the classes from 12 to 18 seconds, 18 to 21 seconds. We didn't have this, we didn't have this. We had the frequency before and the frequency after. For example, the class of 12 to 18, the frequency before training was 10, and the number of people after training was 13. In the class of 18 to 21, the number of adults were 9 before, and the number of adults were 14 after training, and so on and so forth. So there was originally this column, and this column. Let's go to the question so that I start explaining how and why I introduced the other columns. The question says, study the data carefully and use it to draw 2 separate histograms. 2 separate histograms. We have to explain or to come up with histograms. Use statistical methods to decide if this sample shows whether or not the brain training program makes a difference to a person's ability to solve the puzzle. In other words, we are supposed to use statistical methods to prove whether the training is effective or not. And one thing we must know, for the training to be effective, then the people trained should be able to take less time solving the logic puzzle after training as they were, as more than less time after training than before training. Any adult or most of the adults should be able to take less time after training than before training. And I have thought about it, I think, and I thought and I saw, we are supposed to use, or I'm going to use the measure, one measure called the mean and another measure called the median. And for me to use the mean, I have to come up with the midpoint of each and every class. For example, 12 to 18, this is 12 plus 18, which is 30. Divide by 2, we get 15. 18 plus 21 is 39. Divide by 2, this is 19.5. All these are midpoints, which in the previous video we called class representative. These are a midpoint for the first class. These are midpoint for all the classes because the classes are similar throughout. And as you can see, for the mean, we need a column of fx. We need a column of fx. And before training, the number of adults before in the first class were 10. So the first value of fx is this 10 multiplied by the midpoint, which is 10 times 15, which is 153. Please note we are talking about f1 because the frequency before training is different from the frequency after training. So we are having f1 and f2. Before training, this is what is creating the column of f1x. 150, 9 times 19.5, 175.5. 16 times 22.5, 360. 10 times 25.5, 255. 15 times 30, 450. And the sum of the first f1x is 1390.5. Of course, the frequency, the total frequency are both true. They are both 60 and they are equal. And as you can see, I realized that I also need the f2x. The f2x is the frequency times, of course, the midpoint. 13 times 15 is 195. 14 times 19.5 is 273. 16 times 22.5 is 360. And 14 times 25.5 is 357. And 3 times 30 is 90. The sum of f2x is 1275. That is how I came up with with those values of data. Of course, you will see that the class width for all these classes is 6, 6, 3, 3, 3, 6 for all of them. And then we have a column of F1D, the frequency density before training and the frequency density after training. Let me explain the frequency density before training. As we know, the frequency density is always the frequency divided by the class width. So that is 10 divided by 6 is 1.67, 9 divided by 3 is 3, 16 divided by 3 is 5.33, 10 divided by 3 is 5.33, 10 divided by 3 is 3.33, 15 divided by 6 is 2.5. The frequency density 2 is, of course, 13. You divide by 6, which is the class width, which is 2.17. 14 divided by 3, 4.767. 16 divided by 3, 5.33. And 14 divided by 3, 4.67. And 3 divided by 6 is a half, 0.5. That is how we came up with the frequency densities before and after training. Those frequency densities enable us to actually come up with the histogram as asked. Study the data carefully and use it to draw two separate histograms. And the histograms are here. The histograms are here. So we are having before training, the histogram is, of course, the FD frequency density on the y-axis, and of course the time on the x-axis. And as you can see, for the first group from 12 to 18, the frequency density is 1.67, and it is this one. For the second one, the frequency density is 3, and it is here. For the second class, the frequency density is 5.33, and for the fourth class, the frequency density is 3.33, and for the last one, the frequency density is 2.5. That is histogram before training. What about the histogram after training? Frequency density and the timing. After training, for the class of between 12 to to 18. The frequency density is 2.17. It's here. For the second one, the frequency density is 4.67. It is here. For the third one, which is between 21 and 24, the frequency density is 5.33. It is here. For the fourth class, the frequency density is 4.67, which is this. And for the last class, which is between 27 and 33, the frequency density is 0.5. Those are the two histograms that we have. This is before and this is after. Before training and this is after training. This is before training and this is after training. The histograms are there, as you can see. Yes, they are different. Different bars have different frequency densities, and we shall use it now in explaining our next part of the question, our next part of the question, which is suggesting that use statistical methods to decide if this sample shows whether or not the brain training program makes a difference to a person's ability to solve the puzzle. Now, I would want first of all to use the mean so that we can see the average time taken to solve the puzzle before and after. And for us to use the mean, I would want to go back to the table and highlight the fx before divided by the frequency total, which gives us the first mean, which is x1. Mean before is 1390.5. fx before divided by the sigma f, which is 60, and we get 23.2 seconds. The second mean, or the mean after training, is f2x, which is 1275. Divided by 60, as you can see here, it is going to give us 21.3. So that one alone tells me that the average time to solve a logic puzzle is reduced after training from 23.2 seconds to 21.3 seconds. So there is an improvement in the time taken to solve the logic puzzle. The average time is reduced. That means the participants can now reason faster and they use less time in solving the puzzle. That only can already explain that the brain training is effective. Already, it tells me the brain training is effective. But that alone is not enough. So I took it upon myself to be curious about the median in both cases. And because I have 60 participants, I realized that I need to know where does the 30th participant lie, because the 30th participant is actually the median in both cases. And I took the histogram before training, and as you can see, we have the first group giving us 10 participants, which are here. The second group giving us 9 participants, which are here. And the third group giving us 16 participants, which are actually supposed to be in the third group, and they are here. So we know 10 plus 9 is 19. To get to 30, we need 11 participants from here. The first 11. We need the first 11 participants from here. That is why I've indicated 11, because 10 plus 9 plus 11 is actually 30. How do we get 11 in this bar? And because we know that the area of the bar gives us frequency, then we have the height 5.3 times something small here is going to give us 11. In other words, 5.3x is 11. So x is 11 over 5.3. And 11 divided by 5.3, as we all know, let us have it. 11 divided by 5.3, that is 2.1. So 2.1. Now 2.1, from 21, we have 2.1 here. So 21 plus 2.1 is 23.1. That is the median before training. That is the median before training. And as you can see, we have understood that this is 2.1 from 21, because this is 21, plus 2.1 is 23.1, which is the median before. Now, the median after, as you can see, the first group has 13, which are here. The second group has 14 participants, which are here. Already that makes 27. So to make 30, we need these 3. And those 3, we have to have the area of this stripe. So the height is 5.3. So 5.3 times x, they should give us 3. So x should give us 3 divided by 5.3. Let's see. 3 divided by 5.3. Let us see. This is already 0.6, which is, this is 0.6. This was 2.1. This is already 0.6. 0.6 from 21. That is 0.6 from 21. This is what is giving us 21.6. And that becomes the median after training. So you can already see that the median before training was 23.1 and the median after training is 21.6. Again, reduced. The median is reduced. It means that the histogram after training shifts to the side that we have lesser time. Again, the second proof that the training or the brain training is effective, because generally, if the median is 21, which was 23.1, the median is 21.6, and before it was 23.1, it shows that generally most of the people are taking less time in solving the logic puzzle. Thank you, and let us meet in the next video.